We're here at Computex 2024 to look at what might be one of the biggest innovations in water cooling in years and years. This right here is the cold plate of an AIO, but all of it has been metal 3D printed onto here, and it is so flipping cool. Now, how an AIO works is pretty simple. You've got your radiator right here that yeets the heat out. You've got a pump that pumps the water around. But the bit that we are interested in is the cold plate right here. And that can have a huge impact on your performance, because how good this is at getting the heat out of your CPU can be completely transformative to how good your AIO can perform. And what we have here is from Fabric8 Labs. If you look, instead of your typical fins that will just be like skived on, we have complete freedom of what geometry we want. One of the most important things for getting your CPU cool is having loads of surface area of the copper above it. Now, in the past, that was done through skiving. Basically, you take a really sharp blade and a whole bunch of weight, and you just push off a tiny little sliver a whole bunch of times. But the problem is that with this process, you have no control over the geometry besides just how thick the copper is and how big the space is between each fin. Now though, we can do stuff like this, or like this, or like this, and we have complete freedom over the flow path completely. And the most insane thing, they used AI in a way that's not just completely stupid. This is a cold plate that's optimized for Threadripper. So those are massive, and also because Threadripper has multiple dies, you can have some really hot spots on there, and it can be really difficult to get that heat away evenly. But what they have done here is by having that heat map put into an AI model, they were able to generate a whole bunch of different ways to do the flow paths, and they eventually came up with this right here as the absolute best option, and it is crazy. Like, if you look where the die is here, they have some little blockers, so most of the flow will be going over your really hot bits, and then you can have way less flow on the outsides here. It's really freaking cool. Oh geez, we nearly forgot to segue to our sponsor.
Thanks to Private Internet Access for sponsoring our 2024 Computex coverage. Their VPN network spans across 6 continents and 91 countries, letting you access your local catalog of content from all over the globe. Plus, with a single subscription, you get unlimited connections, making it easy to run PIA on practically any device. We previously partnered with PIA for years, and they just concluded their second security audit, putting further emphasis on your privacy and security. So go check out PIA using our link in the description for a special deal with a risk-free 30-day money-back guarantee.
What we've got here is a really cool example of how you can change the pitch of the fins on your heatsink so that you can optimize for the size of your pump. So if you look on this side, they are really, really tight, and that is going to mean that you're going to have a whole lot of pressure and super high velocity of your fluid. But if you do that across your entire heatsink, like you would if you had a whole bunch of really tight skive fins, you're going to need a massive pump to push water through all of that. So instead here, you can see that on the right, it's super dense, but then it gets progressively less dense as we go across, so that you can have a whole bunch of high pressure, high velocity fluid on the right. But then maybe over here, if you don't care as much about the thermal performance, it's a bit easier on your pump system. I've been following Fabric8 Labs for a little bit and their 3D printed water cooling stuff, but what I was not expecting was anytime in like the next 10 years to see it as a commercial product, but that's what we have right here. They have teamed up with Asetek to make a completely 3D printed cold plate, and they say that for every 100 watts that your CPU outputs, this right here can drop 2 degrees Celsius. So say that you have a 300 watt CPU, that means that you have 6 degrees more cooling with this guy. That is crazy. Now, I've been talking about 3D printing, but how the heck 3D printing? Well, it's a thing that's called electrochemical additive manufacturing, or ECAM for short. It's kind of like putting together electroplating and 3D printing into one thing, and also some display technology. It's sort of like OLED. I'll explain it. The process is similar to an SLA printer. So we have our build plate on the top and our print head down on the bottom, which is sort of like an OLED panel, but instead of pixels that create photons to display an image, it has little electrodes that create a current to deposit copper onto our build plate. These pixels have incredible density, 33 microns, and you can have about 2 of them to create a feature for a feature size of just 60 microns, 70 maybe. That's really frickin' small, smaller than a human hair. How you turn that current into copper is by just simply having copper that is dissolved into water, and this is very cheap and very available. It is super common used in electroplating, so it's actually not a very expensive process. And if you know anything about displays, they are pretty much the only thing that has just kept on getting cheaper and cheaper and cheaper. And being able to use that technology for your 3D printer means that we're not having to do any super crazy laser burning copper or stuff like that that's incredibly expensive. Instead, it's actually quite scalable, which is how we have a real product that's going to exist sometime in the near future. Now the process isn't particularly fast. They're getting about 1 millimeter per hour, but you are able to have 4 of these on a build plate at a time, and the machines themselves are not particularly expensive. So even though you need a lot of them, it doesn't get too out of hand too fast. Now Asetek won't tell us exactly when they're expecting for this to hit the market, but they said somewhere around Q3, Q4 this year. And the pricing, again, TBD, but they said it'll be a premium. And given that the Ryogen that it's going into is already pretty premium priced, I don't think it'll be cheap. But that said, the 3D printing technology has lots more uses than cold plates like this. One really cool example that they have here are some radar sensors for cars. So those are looking out and seeing if there's, a car in front of you for your adaptive cruise and stuff like that. But the problem is that a traditional antenna just kind of yeets out electric waves that way. This right here, instead, by using that metal 3D printing, is able to very precisely control it so that you can have a really wide beam this way, but not a very wide beam this way, because you don't care about what's happening on the ground or the sky. You just want to see the cyclist that's right there somewhere. Here you can see the inner geometry of how they were able to create that really cool beam pattern. And one of the best parts is that the whole process is done at room temperature, so you don't have to be doing any crazy stuff like heating up your metal to super high temperatures, just like you don't have to heat up to hit like and subscribe. Huge thanks for watching. Hit like, get subscribed, and just have a great old day. We have a bunch more Computex videos coming to you, and I'll see you soon.